Hello, welcome to the first lesson of the first unit of your MHF 4U course. And the lesson is on the power function, or as we more often refer to it, the polynomial function. Now, as you are watching this video, you should have the worksheet that is also entitled LO 1.01, the power function, open in front of you. If you have not yet read the first page of preliminary notes on that document, please pause this video now and read those preliminary notes. Then, when you get to the part where it says you are now ready to start lesson 1, start the video again and away we'll go. Now, what do we mean by the term power or polynomial function? At its simplest, we're talking about a function where the variable, let's get rid of that mistake there, where the variable is the base of every term and the exponent is a whole number. So, for example, a function that looks like this, f at x equals 2x cubed plus x squared minus 5. That would be a power function because in every term the base of the power is the variable and the exponent is a whole number. Now, you've seen many functions like this in the past. Just for comparison, let's look at some functions that you've seen also that are not power functions. For example, let's take a look at this. This is a familiar one. A radical function. Now, the variable is definitely in a base here, and it can even be written in the form of a power. Remember that? But it is not a power function. Why does it not meet our definition? Definitely the base is a variable, but look at the exponent. Not a whole number. Not a power function. Can you think of another example that is not a power function? Here's an important one. You've seen quite a few of these in the past. This is an exponential function. It's important, but it's not a power function. Why not? The base is a whole number. The exponent is a variable. In other words, the opposite to what our definition is. Try to think of one more. You've seen this before as well. Definitely not a power function. It is, of course, a trigonometric function. Now, these are all very important functions, and we will be spending quite a bit of time on them in this course, but they are not power functions, so not today. Now, it is quite important that you get it clear in your head what a power function is and what a power function is not. This is the formal definition of a power or a polynomial function, and it does look pretty horrible. Not really fair to show you this on the first day. But if we look at it a little bit closer, we can see that it's not quite as bad as it looks. Every term has this form, a sub n x to the power of n, or quite simply a number times a power of x. A sub n is quite simply the coefficient of the term. You know that word, the number that goes with the variable in a term. And x to the power of n is the variable raised to a power. In the function that we looked at earlier, this one up here, the first term, 2x to the power of 3, the 2 is simply a sub n, or the coefficient, and the x to the power of 3 is quite simply the x to the power of n part, where n is equal to 3. And then we add the next term, which is just the next coefficient, and n minus 1 is the power, or plus 1 x to the power of 2, and so on. Just a fancy way of writing what we have already said. Note that n has to be a whole number, the exponent. The coefficient can be any number, a real number. Now, before we go any further, there are two terms that you need to understand. The first that we're going to consider is leading coefficient. Which coefficient in the expression is the leading one? And what is it? Well, for a change, this actually means exactly what it says. It's fairly easy. But before we do talk about it, we should address another important issue. The notion of descending order. You should take a note on this if you haven't heard of it before. When we write a polynomial, we should write it in order of the number of the exponent, or the power on the variable. So if we have an exponent that looks like this, y equals 2x plus x squared plus 1, the first term here has x to the power of 1, then x to the power of 2, then x to the power of 0, not in order. We would rewrite this with the highest power of x first, then the next, then the next, descending order. You should always write polynomials in descending order. Now let's come back to leading coefficient. If your polynomial is written in descending order, the leading coefficient, usually called a, or denoted a, is the coefficient of the first term, or the term with the highest power. Take a look at the two examples on this screen and make sure that you know what the leading coefficient for both of them is. On this one up here, 2 is in front of the term with the highest power of x. It is the leading coefficient. And here, it's 1. Now, the other term that we need to worry about is the degree, or order of the polynomial. They're used interchangeably, and you've come across this before. This is simply the highest power of the variable that occurs in the polynomial. The highest power of the variable. So, for example, if f at x is equal to 2x cubed plus x squared minus 5, the highest power here is 3, and this is a third degree or third order, otherwise known as cubic. If the highest power of x is 2, it is second degree or second order. Can you remember the word for that? Quadratic. And what about first order? Well, that would be a linear function. We don't have fancy words for too many more. A fourth order is quartic, a fifth order is quintic, but we don't use those very often. At this point, please pause the video, and on your worksheet, please answer the two questions on leading coefficients and degree of functions on your worksheet. Then restart the video. Okay, this is the function that you were looking at on the worksheet. For the leading coefficient, did you say it was 2? If you did, can you see why that is not correct? The function is not written in descending order and needs to be rewritten so that the term with x to the power of 5 is first. And now we can see that the leading coefficient is in fact negative 3. If you got that, well done. And we can also see that the degree of this function is the highest power of x, which is 5. This is a 5th degree, sometimes called quintic function. If you got that, well done. One final idea before you can take a short break. We need to know a little bit about symmetry with functions. Not a lot, just a little bit. If you have a function that looks like this straightforward one here, you probably recognize it, where a vertical line forms basically a mirror line and divides the function exactly into two equal parts, one of which is a reflection of the other, we say that the graph has line symmetry. At this point, you really just need to know what that is, and you need to recognize it when you see it. Now, over here, we have a different situation. There's clearly some kind of symmetry here, but there is no vertical mirror line. However, if you look at this point, you should be able to see that if you rotate the image about that point, either clockwise or counterclockwise, you should be able to see that it will eventually turn so that it rests exactly upon itself again. This is said to have point or rotational symmetry. And again, you just need to know what it's called, and you need to recognize it when you see it. And this is the end of the first video. You can take a short screen break now.